of what this particular chapter comprises of. So there are three topics to be covered under surface chemistry. It's a term 2, which means that from now onwards you have to prepare for descriptive part as well, because both objective and descriptive part will be coming. So in the surface chemistry part, it comprises of three subtopics: adsorption, catalysis, and colloids. Okay, so these are the three subtopics that needs to be covered under surface chemistry: adsorption, catalysis, and colloids. So we need to start away with what is called as adsorption. Adsorption mane ki hetu amar buzibo lagibo. Most of us are familiar with what is called as absorption, because that is the most common term which is used in English language. Okay, something is absorbed. But today what we are going to discuss is not absorption, rather we are going to discuss adsorption, AD, not AB. I hope my voice is crystal clear to all of you.
Yes, sir.
Okay. So adsorption mane ki, what do you mean by the term adsorption? And how does it differ from that of absorption? Absorption of ke, adsorption beleg keneke. So in order to understand this, let me give you two different examples. In the first example, let us take a closed container saturated with water vapor. Okay, so there is moisture present in this particular container, and same way we are taking another vessel with moisture in it. Now in these two vessels, if you put in the first vessel, if you put calcium chloride, let us say I am putting calcium chloride, CaCl2, and in the second one, if I put silica gel, then what do you observe in these two different containers? One containing calcium chloride and one containing silica gel. It is observed in calcium chloride container that water gets uniformly distributed both in the bulk of calcium chloride as well as on the surface. Okay, the uniformly the water will be distributed both over the surface as well as the bulk. Bulk means inside portion. But in silica gel, it is observed that water molecules are present only on the surface, but they do not go into the bulk. So the first type of example which is occurring is referred to as absorption, and the second type is called adsorption. Are you getting the difference? Dutar major difference to buzi paisa? In absorption, AB, you have an equal distribution. Doesn't matter whether it is bulk or within bulk or surface. But in adsorption, there will be acceptance only on the surface. It will not be going into the bulk. So you must have seen, you must have observed that whenever you buy some new electronic equipment, so in the new packing or new package, there is always some kind of silica gel pillows which are put inside. And why these silica gel pillows or silica crystal pillows are put inside? So that the extra moisture, whatever is present inside the box, is taken by the bags of silica. Otherwise, the moisture may create problem in the electronic equipments. So silica gel, or you can say silica crystals, is generally put to adsorb. So hence the basic difference between absorption and adsorption is, whereas in absorption there is uniform distribution of the substance both over the surface as well as the bulk, but in adsorption there is distribution only on the surface but nothing goes into the bulk. Understood? Can I proceed further? Okay. So we need not discuss the absorption anymore, because for our syllabus what we require is adsorption, not absorption. So let us see that what are the components present in the adsorption. Adsorption of key component thake. So there are two components in the adsorption process. The one which adsorbs is called the adsorbent. জুনে adsorb করে তাক কোয়া হয় adsorbent, which adsorbs. And the other which gets adsorbed is called adsorbate. Which gets adsorbed. So these are the main components of adsorption. One which gets adsorbed, which comes on the surface, is referred to as adsorbate, and the other which adsorbs, belegok june adsorb kore tak koa hoy adsorbent. So the question arises, why will a substance adsorb other substance? So a simple theory states that when anything is present at the bulk, any molecule is present in the bulk, so it is equally attracted from the molecules in the neighborhood. And when there is equal attraction from all the sides, the net attraction on the molecule at the bulk is nil. Okay. But when you talk about the surface, so there are molecules only below it, there is no molecule above it. So as a result, there is an unbalanced force acting upon it, and therefore any molecule which wants to come in gets adsorbed. So that is one of the theories which states that due to the imbalanced force present on the molecules present at the surface, they will always have the tendency of adsorbing the molecules. So that is the main reason that has been given why adsorption is occurring. So amount of adsorbate that is getting adsorbed is denoted by small x, and the mass of adsorbent that is adsorbing is generally given by small m. So the ratio x by m gives us the measure of how much adsorption has occurred. Adsorption kiman khini hoise a particular ratio amak kobo. So this way we can say that x by m is the ratio of adsorption occurring. Adsorption amount. Or sometimes it may also be used to specify rate of adsorption. Rate of adsorption. So hence we say that adsorption is nothing but the phenomenon in which there are two different type of substances. One is getting adsorbed and the other is adsorbing. And if adsorbate is given by small x and adsorbent is given by small m, then the ratio x by m gives you the rate of adsorption. Any doubt up to this much?
Sir, ভিতৰটো কি বুলি কয়?
কোনটো ভিতৰত মানে?
Sir, surface আৰু surface ৰ ভিতৰৰ পাৰ্টটো কি বুলি কয়?
Bulk. This is referred to as bulk.
Sir, spelling?
Any portion inside is called bulk.
Okay, sir.
Okay. Any portion inside is called bulk. And anything that is on the surface, of course, the term surface is used for that. Can I proceed further? Clear
Yes,
up to this much? Okay. Now suppose there is some function going on in an auditorium, and you know that auditorium has fixed number of seats in it. So initially the seats were vacant, people keep on coming in and occupy their positions in the seat, and the time will come when no more seats will be available. And if there are no seats available, then of course the new people who want to sit, as seats are not available, they will not be able to sit, and they are obviously bound to stand, and they will be able to sit only when the people who had already taken the seats leave their places. So exactly in the similar way, when we have an adsorbent, when it was fresh, so obviously it will have too many vacancies on it, and when the adsorbate keeps on coming, so they will keep on occupying the space at the surface. Adsorbate keta ahibo khali thai thaka karne they will keep on occupying, and as the process continues, a time comes very soon when there will be no space left, isn't it? Tenko eta time ahibo na? When all the vacancies at the surface will be completely occupied. Yes or no?
yes.
It will continuously keep on going. Is it possible to continuously keep on showing the adsorption, or at a particular moment of time the process of adsorption will stop? What do you think?
Sir, will stop.
Will stop. That means initially when the adsorbate molecules are coming and getting adsorption or getting adsorbed, so we say that the process of adsorption is going on. But after some time, we will not notice any adsorption because of the fact that the vacancies, whatever were present, are completely filled up. And one might think that adsorption will stop, but actually it is not. Adsorption still goes on. Adsorption is still going on if all the positions have been blocked up already by the adsorbate. The answer to this question is initially when there is adsorption, so the molecules will block the spaces, but after some time, it is just like saying that some people are getting bored with the program and some of them will try to leave the surface, and this leaving the surface is referred to as opposite of adsorption, which is called desorption. And as I said, that some people who enter the auditorium to fill the seats are unable to do so because all seats are filled up. But suppose some people are getting up, and when they are getting up, so a time will come when more places will be vacated. And when more places will be vacated, so in order to fill up those, you will get adsorption. And this way we can say that when the rate of adsorption and desorption occurs simultaneously, becomes equal. And we have learned in class 11 that whenever the rate of forward process becomes equal to rate of backward process, this process will be called equilibrium or not?
Yes.
তার মানে আৰম্ভণি অকল adsorption হৈ আছিল, অকনমান পিছত desorption আৰম্ভ হ'ব, and after some time the rate of adsorption and desorption will be carried out simultaneously at equal pace, and we say that equilibrium is established. At the point of equilibrium, adsorption is still going on, desorption is also going on, but because the rate of adsorption and desorption are going in equal rate, equal speed, one cannot make out the difference. So if it is said, will adsorption stop after some time? The answer to this question is no. Adsorption will never stop. Adsorption will continue. But once equilibrium is established, you cannot make out the difference because the rate of adsorption and desorption becomes equal. Understood?
Yes.
Others, I'm getting only one voice. Others are there or should they have? Amritpal,
Yes, sir.
समझ में आ गया?
Yes, sir.
तो एब्जॉर्प्शन क्या होता है? बंद हो जाता है कि चलता रहता है? एब्जॉर्प्शन एक पर्टिकुलर टाइम में बंद हो जाता है कि स्टिल कंटिन्यूज?
So continue.
It continues. लेकिन अगर it still continues, why we cannot make out whether it is going on or not after a certain moment of time? क्यों ऐसा लगता है कि the process of absorption has come to an end even if it continues? बता सकते हो? Anyone? वरना you?
Sir, rate of adsorption और rate of desorption to equal हो जाए, equilibrium state
Because
होता है.
the rate of adsorption and the rate of desorption becomes equal. So at equilibrium, even though the processes are still going on, you cannot make out the difference. Why? Because it is just like saying that if I give you rupees 500 and take back rupees 200, you can make the change because obviously মই যদি তোমাক 500 টাকা দিও আৰু ঘুৰাই যদি 200 টাকা লৈ লও তোমার তাত 300 টাকা থাকি যাব. So there is some difference. But if I give you rupees 500 and take back rupees 500 from you, so even though someone will say that there is no change because so what I cannot say that I did not give you. I gave you, but the net resultant is 0 because whatever I gave you, I took it back. So equilibrium exactly is the process where the rate of forward reaction is equal to the rate of backward reaction, and in such kind of processes you cannot make out the difference. And in all sorts of equilibrium, whether it is a physical equilibrium, whether it is a chemical equilibrium, you cannot make out the difference because rate of forward reaction is equal to rate of backward reaction. Again, as a whole, I am explaining it. Initially, when full of vacancies were there on the adsorbent and you are making the adsorbate to come near it, there will be only adsorption. And after some time, some molecules will show desorption. They are coming out of the surface. And after some time, it is further observed that rate of adsorption becomes equal to the rate of desorption. And at that particular moment of time, even though it seems that everything has come to an end, but actually it is not so. You cannot make out the change because of the fact that equilibrium has been established. Is it understood up to this much?
Yes, sir.
So we have learned the terms like what is adsorption, what is opposite of adsorption, that is desorption. What are the two components of adsorption? One is called adsorbent, which adsorbs, and the other is called adsorbate, which gets adsorbed. Thereafter, we'll talk about the next very important topic, that is thermodynamics. Thermodynamics of adsorption. Listen very carefully, because this is one of the very important topics considered under adsorption topic. Thermodynamics of adsorption. Now, there is a very famous equation given by Gibbs and Helmholtz, which is referred to as Gibbs-Helmholtz equation, with the help of which we can predict the spontaneity of a reaction, whether a reaction is spontaneous or not. We can make it out with the help of Gibbs-Helmholtz equation. This is called Gibbs-Helmholtz equation. Remember this equation, the basics of which was there in class 11. And if delta G is negative for any process, it is said to be spontaneous. If delta G is positive, the process is referred to as non-spontaneous. And if delta G is equal to 0, the process is said to be at equilibrium. So these are the three results which are possible for delta G. And for any process, if delta G is negative, that means the Gibbs free energy is decreasing, then it means that the system is utilizing this free energy to work on its own. That is why it is decreasing. And when I use the term spontaneous, I mean to say that such processes do not require help of any outside source. It is just like saying that sometimes when you are studying on your own without taking help from anybody, then we say that obviously the process is spontaneous. You are utilizing your own concepts, you are utilizing your own brains to understand the concept. But if you depend upon others for everything, then you are not utilizing anything of your own. And therefore, as long as the outsider is helping you, you are capable of carrying out the job. And the moment the outside help stops, your process will also stop. And that is called non-spontaneous process. And equilibrium we have already discussed. When rate of forward reaction becomes equal to rate of backward reaction, it is referred to as equilibrium. Now, what kind of process is adsorption? We are going to apply this equation on adsorption. What kind of process is adsorption? When you have an adsorbent and when the adsorbate is coming and sitting on the surface, my question to you is it coming on its own or you are forcing it to do so? Whenever adsorption is coming on its own, you are not forcing it. It's just like saying that when you put the silica gel in water vapor enriched atmosphere, you are not forcing the water vapor to come on it. The water vapor molecules will on its own approach and will occupy the vacant spaces of the silica gel. That means as the process is going on its own, it's a spontaneous process. And for spontaneous process, what value of delta G should I give? Will it not be negative? Yes?
Yes.
For any process which goes on its own without external help is said to be spontaneous. And for spontaneous, delta G is negative. So, for this, we have got the value of negative. Next question. During this process, what is happening to the delta S? Now, those who have forgotten the meaning of delta S, let me tell you, S is called entropy of a system. What is measured by entropy? The randomness, disorderness, ami অসমীয়াত কওঁ উৎপাত, এটা particular systemত যিমান উৎপাত কৰিব molecules কেটা, we call it to be more random with high entropy. And যদি molecules কেটা ধীর স্থির হৈ যায়, they become static or they do not randomly move. So we call the system to possess lesser entropy. Now tell me, during the adsorption process, what do you think is happening to the entropy of the system? Is it increasing or is it decreasing? What do you think? Entropy of the system during adsorption process will increase. Molecules ketar utpat baribo. The molecules ketar, they will be more disciplined after adsorption.
Sir, delta S should be positive.
Delta S is positive is given when there is increase in the entropy. Delta S is negative when there is a decrease in entropy. My question to you is, during the adsorption process, entropy of these molecules are increasing or is it decreasing?
Decreasing.
What do you think? Abhigyan, can you tell me? Entropy to increase kori ase ne decrease kori ase during adsorption process? Abhigyan Bhattacharya, Abhigyan Kumar, duta Abhigyan ase, jikono eta kole hol. Please answer me, because until unless you interact with me, I will not be able to understand whether you are Parvez. Can you answer me? Entropy process or decrease kori ase ne increase kori ase? Tumar mote ki? So hoy answer to decrease korise ba increase korise hobo. So at least you can try it out. Tushar Jyoti, can you tell me?
Sir, decrease.
Decrease korise. Kyo decrease korise boli koisa? Karon jetia he absorb hua nasile, it was more random or not? It was disordered or not? Yes or no?
Yes.
এতিয়া ধৰা তুমি ক্লাছৰুমত টিচাৰজন আহা নাই, so you people are roaming here and there. The moment the teacher enters the class, you get into the classroom and you occupy your specific positions in the classroom. So during this process, what will I call? Your entropy is decreasing or your entropy is increasing?
Decreasing.
It is decreasing. Why? Because your randomness has decreased, your disorderness has decreased. But after the class is complete and the teacher goes out, again you move out of the room. So in that case, what is happening to your entropy?
Increasing.
It is increasing. Have you understood? When the entropy increases and when entropy decreases?
Yes.
Oh. So here, before adsorption, it was more random, it was more disordered. After adsorption, it has become less random and more disordered. So during the process of adsorption, delta S is also negative, because if entropy decreases, the delta S is said to be negative. Clear? Clear out your doubts if still you have got doubts or questions or not understood anything.
Sir, এই term কেটাৰ নাম কি হয়? Delta G, delta H.
Delta G whole Gibbs free energy change. Now you know?
আৰু বাকী কেটা?
Delta H is enthalpy change and delta S is entropy change. And what is capital T? It is temperature expressed in Kelvin.
So temperature is constant, right?
Temperature is constant at a
And
particular
delta S is
place.
negative.
Delta G is negative. Moi delta G negative kyo koisu? Karan ei process tu nije nije hoy ase. মই ডেল্টা এছ নেগেটিভ কিয় কৈছো কাৰণ during the process randomness decrease হৈ আছে এতিয়া with the help of delta G negative and delta S negative we will find out what should be delta H, and that is the objective of my discussion. During the process of adsorption, whether energy will be released or whether energy will be absorbed, that is what I want to prove it mathematically. Up to this point, is it clear or not? Delta G negative kya hoy aru delta S negative kya hoy?
Sir, delta S or full form ki ase?
Delta S is change in entropy. Delta
Okay,
mane change and S mane entropy. Entropy e ki bujhaye? Entropy e ki bujhaye? Yes. What does entropy of a system signifies? Tell me if you don't know. I'll explain it.
sir, don't know.
So randomness.
Randomness. Okay, at a particular system of kiman randomness ase, oscillata ase. That is measured in terms of S by entropy. Koasun, out of solid, liquid, and gas, which physical state has maximum entropy?
Yes.
Obviously gaseous. Around gas molecules are moving randomly. So when you do not have any aim and objective in your life and you proceed haphazardly, so I call you as random or disordered. But if you have aim and objective and you focus, you move according to your aim and objective, so we call you as ordered. So order jiman besi hobo ami kom entropy to imane kom aru disordered jiman besi hobo entropy to besi. Buji paisa kya?
Yes, sir.
Oh. Now this is negative. Delta S is also negative. Can you tell me, by comparing mathematically, what should be the delta H value? Should it be negative or should it be positive? Rest is mathematics. Delta G hoday negative hobo.
Negative.
Delta S hoday negative hobo. Delta H to ki hobo lage? Etai koise positive, etai koise negative.
Sir, negative.
Think about it.
Negative. Negative.
Negative hobo. Can you explain why delta H will be negative?
Sir, because delta G is negative.
If I put delta S as negative, will not the second term will become as a whole positive?
Yes.
এইটো যদি নেগেটিভ হয় নেগেটিভে পজিটিভ হ'ব না নাই? Yes,
Hobo.
but overall value to কি হ'ব লাগে?
Negative.
Overall value negative হ'ব লাগিব. তো second term to যদি positive হয়, overall যদি negative বনাব লাগে, will not the delta H be negative and greater than that of this?
Yes.
বুজি পাইছা? Now should I repeat it once again? Is it clear or should I repeat it once again? Tell me frankly. It is clear? Again I'm repeating. Delta S is negative. If you put negative here, then the second term will be positive or negative as a whole? The second term will be negative or positive if delta S is negative? What? Tell me.
Negative.
Positive.
This is negative and there is already a negative present. So negative into negative to ki hoy? Positive
Positive.
hobo. Oh. এইটো যদি positive হয়, overall value to negative দিয়াই আছে, so will not the delta H be greater than the second term as well as it should be negative? Isn't it? Nagi?
Yes, sir.
Oh. So we can say that delta H is also negative. This is a very, very important information, that all the three thermodynamic terms, Gibbs free energy change, entropy change, and enthalpy change, all three of them are negative in nature. So can you tell me, if delta H comes out to be negative, what is this process, endothermic or exothermic?
Exo.
It is exo. That means during the process of absorption, there will always be some energy release, and that amount of energy release, when 1 mole of an adsorbate is absorbed during the process, is referred to as enthalpy of adsorption. So write down the definition of enthalpy of adsorption. Which is symbolized as delta AdSH. So enthalpy of adsorption is exothermic or endothermic in nature?
Exothermic.
It is exothermic. Okay, so enthalpy of adsorption is always exothermic. So what is the definition of enthalpy of adsorption? You can write the amount of heat evolved when 1 mole of an adsorbate, adsorbate can be gas or liquid, when 1 mole of an adsorbate, gas or liquid, is adsorbed on the surface of adsorbent, is called enthalpy of adsorption. It is always negative. Negative means exothermic. So whenever an adsorbate comes and joins the adsorbent, sits on the surface of the adsorbent, just like if you want to watch a movie and go to the auditorium to watch the movie, so if you want to sit on the seats, you have to spend some money. So similarly, whenever the adsorbate comes, sits on the surface of adsorbent, in return, it has to release some amount of energy, and that type of energy which is released during the process when adsorption occurs is referred to as enthalpy of adsorption. Is it understood?
Yes, sir.
Clear or not? Anyone having doubt? Have you understood the fact that why enthalpy of adsorption is always negative? Why it can never be positive?
Yes.
Yes. So on the basis of what you can say that enthalpy of adsorption will always be negative?
Delta G and delta S.
On the basis of the signs of delta G and delta S, because delta G and delta S are always negative. So therefore, mathematically, if you proceed through Gibbs-Helmholtz equation, then delta H has to be negative to make both delta G and delta S negative. And we have already discussed that why delta G should be negative. Delta G should be negative because adsorption process is spontaneous, goes on its own. Why delta S is negative? Because obviously during the process of adsorption, there is decrease in the entropy. So if both are negative, to make overall value negative, delta H has to be negative. Yes, understood up to this much?
Yes, sir.
Can I proceed further?
Yes.
So thereafter, we'll talk about two different types of adsorption processes. What are the two different types of adsorption? Let us see. Types of adsorption. Types of adsorption. So adsorption has been further subdivided into two different types. One is called Physisorption, and the other is called Chemisorption. And it is quite clear that the term physi stands for physical and the term chemi stands for chemical. So to understand it in a better way, we can say that if an adsorbent invites the adsorbate and the force which is responsible in holding them together is weak van der Waals force. It is referred to as Physisorption. There is no chemical reaction going between the reactant and the product. So if the force which is responsible in holding the adsorbate on adsorbent is weak van der Waals forces, then it is referred to as Physisorption. It is relatively weaker form of adsorption. Now, if the force of attraction between the adsorbate and adsorbent is poor, what do you think about enthalpy of adsorption? Will the energy released will be very high, or will the enthalpy of adsorption released will be very less?
Less.
It will be less, because the amount of energy that is released always depends upon the interactive forces, the magnitude of interactive forces. If you are less interested in anything, so you're not going to spend much of money to buy that thing. But if you are highly interested, you don't look at its price if you are capable of buying it. So no matter what, you want to buy it even by paying more amount. So here, as the interactive forces between the adsorbate and adsorbent is very poor, because van der Waals forces are considered to be weakest forces. So they simply come and sit, and no special forces are involved in holding them together. So therefore, the enthalpy of adsorption that is involved is very poor, very low. Now come to the chemisorption. When an adsorbate comes on the adsorbent and there is a chemical reaction responsible for holding the adsorbate on the adsorbent, there is some kind of chemical reaction as a result of which some chemical bond is developed in between. Then we call it as chemisorption. So obviously, as it's a chemical reaction, and chemical reaction does not take place between any two molecules. They have to be highly specific in nature. যিকোনো দুটা মলিকিউলক লগ লগাই দিলে কেমিক্যাল রিঅ্যাকশন নহয়। Yes, van der Waals force হ'ব পাৰে, গতিকে they are highly specific in nature, they are non-specific in nature. So it is just like saying that in case of chemisorption, as the process responsible between the two is a chemical force, chemical reaction, so there will be product formation occurring on the surface, because at a chemical reaction jetya hobo, two different molecules react with each other to form a third product. It means during chemical reactions, product formation will occur on the surface, and the product form will be different from that of both adsorbent as well as the adsorbate. But no such chemical reaction is occurring, and therefore the adsorbate and adsorbent are not losing their identity. Whatever they were before the adsorption, they remain the same even after the adsorption. But in chemical reaction, as there is a chemical reaction going on in chemisorption, as there is chemical reaction going on, so therefore there will be product formation, and when there is a product formation, a third type of substance will be formed, releasing a tremendous amount of energy. So if the amount of energy released in this case is, suppose, H1, and amount of energy released in this one is H2, which value is higher? H2 is higher or H1 is higher?
H2.
H2 is higher. Why? Because it's a chemical reaction, and during chemical reaction, chemical bonds are formed, and because chemical bonds are formed, so energy released will be very high, because obviously stronger the interaction, more will be the energy released. But here relatively the amount of energy released will be lesser. Next thing, out of the two, where it is relatively easier to remove the adsorbate?
Physisorption.
Obviously Physisorption, because they are present together through weak van der Waals forces. But here it is very difficult to remove one from the other, because once they have started reacting, it will be very difficult to remove, as they are getting converted to some other products. Next difference is enthalpies of adsorption obviously are different. For Physisorption, enthalpy of adsorption is very poor. For chemisorption, enthalpy of adsorption is very high. Out of the two, which do you think is specific and which do you think is non-specific?
The second one is specific.
Yes, very good. Second one is specific, because when we talk about chemical reaction, the reactions always take place between two specific type of molecules. No two any molecules chemically react with each other. So therefore chemisorption is specific in nature, whereas Physisorption is non-specific in nature. Is it clear?
Sir, silica gel to Physisorption hoy na?
Silica gel of silicon is not chemically reacting with water, so therefore it's a Physisorption.
Okay, sir.
Karon tumi silica gel to jetya ulai aniba, and you can again heat it up, and when you heat it up, water will go away. That means it was not a chemical reaction, it was a Physisorption. Yeah?
Yes, sir.
So I hope up to this much is it understood to everyone? Adsorption kak koy, absorption ot koy, adsorption keneke different. What is the thermodynamics of adsorption? And most importantly, what are the two different types of adsorption? Is it understood?
Yes, sir.
Okay. So next day we'll continue further with details of Physisorption and chemisorption, because one common question that many a times that is asked is, state the differences between Physisorption and chemisorption. So some points we have discussed today, some points we'll discuss in the next class. Thank you.
Thank you, sir.
So let us try to understand the differences between Physisorption and Chemisorption. Differences between Physisorption and Chemisorption. So as far as the Physisorption's force of attraction is concerned, what holds the adsorbate and adsorbent in Physisorption together? It is physical adsorption See, because it is a term 2 topic, you can expect descriptive questions from it, subjective questions from it, and therefore I want you to write down. Yes, what is the force responsible in Physisorption in holding the adsorbate and adsorbent together? Is it strong force or is it weak force? Yes, is it a strong force or weak force? Anyone? And if it is whatever out of the two, what is the name of the force? Can anyone tell me? So write down, it arises. Please go through the video. I have asked you to go through. Otherwise, later on, you will mix up the things. It arises because of weak van der Waals forces. It arises because of weak van der Waals forces. Tarmane, if the adsorbate and adsorbent are held together by weak van der Waals forces, then it results in Physisorption. But in Chemisorption, it's a chemical reaction going on and bonding will be strong. So we can write it is caused by chemical bond formation. That means the adsorbate and adsorbent chemically react with each other and therefore it is caused by chemical bond formation. Point number 2. It is non-specific in nature. It is non-specific in nature. What is the meaning of the term non-specific? See, when I talk about van der Waals forces of attraction, it can take place between any two molecules, whether they are similar or different, and no specification is required. But as far as the chemisorption or chemical reactions are concerned, the two molecules that chemically react with each other have to be specific in nature. If you take two molecules, any molecules, they will not chemically react. Specific molecules chemically react with each other. It is highly specific in nature. It is highly specific in nature. Point number 3. It is reversible in nature. Now, what is the meaning of it is reversible in nature? The meaning of it is reversible in nature means because the force of attraction between the adsorbate and adsorbent is weak force, van der Waals force, the more easily it comes and binds here, more easily it can be removed as well, because the force of attraction is not that strong, because of which it is reversible in nature. So it can go both ways. Okay. But here, as it is a chemical reaction, once chemically the adsorbate and adsorbent react to form products, you cannot get them back. And therefore it is irreversible in nature. Once gone means gone. Once reacted means reacted. You cannot get back the original reactants. And that is the meaning of it is irreversible in nature. Enthalpy of adsorption is low. How much low? Nearly 20 to 40 kilojoules per mole. Now, what is enthalpy of adsorption? Last class we have discussed that whenever adsorption occurs and adsorbate comes on the surface of the adsorbent, during this process, some energy is released. When the amount of adsorbate adsorbed is 1 mole, whatever amount of energy is released is called enthalpy of adsorption. So why the enthalpy of adsorption is low for Physisorption? Because it is weak bond, and weak bonding will result in obviously very lesser amount of energy. Enthalpy of adsorption is high. So you can see that it is many times higher than that of 20 to 40 range, indicating that the amount of energy released is high, which means that the bonding is very, very strong in nature. Number 5, no appreciable activation energy is required. Now, what is the meaning of the term activation energy? This term activation energy makes sense only during the chemical reaction. When you start up any chemical reaction, you need to supply a minimum amount of energy so that the reactants get geared up and they get converted to the products. But because it is not a chemical reaction, it is simply the van der Waals force of attraction. So you don't require any activation energy to carry out the process. But because the right hand side is a chemical reaction, so high activation energy is required. High activation energy is required. Point number 6, it decreases with increase in temperature. Okay, so suppose Physisorption has occurred, adsorbate has come, and they have been adsorbed by the surface of the adsorbent. When you provide temperature, if you increase the temperature, because the bonds are weak, so it will weaken the bond. And when it weakens the bond, So automatically desorption starts occurring and the adsorbent leaves the adsorbate, and therefore it decreases with increase in temperature. Now let us see what happens in case of chemisorption. It first increases with rise in temperature, and thereafter decreases. It first increases with rise in temperature and thereafter it decreases. Why is it so? Because it's a chemical reaction, and any chemical reaction increases with increasing temperature, and that is why initially there will be increase in chemisorption with rise in temperature. But at a time when the reaction is completed and no more product formation occurs, after that, if you further keep on increasing the temperature, it will behave like a simple Physisorption, because no longer any chemical reaction will be possible, and the further increase of temperature will decrease the adsorption process. So hence we can say that if I plot a graph, have you written the first 2 points? Can I rub it?
Yes, sir.
So if you look at the graphical representation of adsorption versus temperature at constant pressure, then let us see what happens. So suppose this is the adsorption rate x by m. I have discussed what is x by m. You can go through. Versus temperature for Physisorption at constant pressure, because pressure also affects the adsorption process and temperature also affects. So if you want to find out the effect of any one of them, the other must be kept constant. So these graphs are called isobars. Okay, and what is the meaning of the term isobars? The graphs which are calculated at constant pressure. So as you can easily see that with the rise in temperature, the x by m is gradually decreasing. And this is what has been stated, that it decreases with rise in temperature or increase in temperature because of the fact that weak van der Waals forces further weakens when you are increasing the temperature. But the same, if you plot a graph for chemisorption for x by m versus temperature, then being a chemical reaction, first the rate of reaction increases, and once the adsorption is completed at this point, okay, at the tip, when all the chemical reaction is over, so it will simply behave like a Physisorption, and thereafter if you further increase the temperature, so there will be decrease in the adsorption process, and that is why we get difference in the behavior of the graphs in Physisorption and chemisorption. Let us now move on to point number 7 and last. So they are more than sufficient if you are asked the question on differences between Physisorption and chemisorption. Point number 7 says it results in the formation of multimolecular layers on adsorbent molecule. Now, what is the meaning of the term multimolecular layer? It means that suppose this is the adsorbent. So at first, there is one layer of adsorbate coming, and the force responsible, of course, is van der Waals forces. There can be another layer of adsorbate which can come, because the force that is responsible is weak van der Waals force, and being non-specific in nature, it can exist between different molecules as well as same type of molecules as well. So as a result of which you will see that there is a multimolecular layer formation. But when we are talking about chemisorption, it will never result in multimolecular. Rather, it will result in the formation of unimolecular layer. Uni means single. Why? Because the chemical bonds are highly specific. And if they are highly specific, chemical bond never will take place between same type of molecules. You cannot expect another layer to come and sit on the first layer, because similar type of substances never chemically react with each other. And therefore, you can expect only one layer of molecule on the adsorbent. You cannot expect multimolecular layer. So just try to understand all the points of differences. Any point which is not clear to any one of you, please tell me. Any point which you think you need clarification, you can ask me. Are all the points clear? Say yes or say no.
Yes, sir.
Okay. So this is a very, very important question that is generally repeated almost every year. The differences between Physisorption and Chemisorption. Those who have not gone through the first class video, please go through it, because then only you can understand today's class. And that is what I had written yesterday, that without going through the first, you cannot understand the second. Okay, so after this classification of adsorption into two types, the next thing that we will discuss is factors affecting the adsorption of gases in liquids. Factors affecting the adsorption of gases in liquids. What are the factors that affect the process of adsorption? Let us try to understand it. And every factor is equally important. We first talk about nature of adsorbent. Nature of adsorbent. So obviously, the process of adsorption involves two species, one of which is adsorbent and the other is adsorbate. And both are equally important. Just like in a teaching learning process, the role of both the student as well as teacher plays important role, because that completes the process of teaching and learning process. If any one of them is having some kind of lacking, then the whole process will be hampered. So likewise, we have both adsorbent and adsorbate responsible for the process of adsorption. So if you have an adsorbent which is porous in nature, which easily invites the adsorbate, so that will make the process relatively faster. So write down. A gas is adsorbed in different amounts on different adsorbents. As for example, H2 gas is strongly adsorbed on nickel surface, while on alumina surface it is adsorbed weakly. A gas is adsorbed in different amounts on different adsorbents. So it is the same hydrogen that has been taken, but when the surface is nickel, the adsorption is very strong, and whereas if the surface is alumina, then the rate of adsorption is very poor. So here the adsorbate is same in both the cases, but because the adsorbents are different, so they will show different kind of adsorption. Number 2, nature of adsorbate, which is of course gas, the one which is coming on the surface. So last year under states of matter chapter, we have come across a term called critical temperature. So let us first of all try to understand what is critical temperature. Critical temperature is that temperature above which any gas cannot be liquefied. Every gas has a particular temperature below which only the gas can be liquefied. And this critical temperature differs from gas to gas. If the critical temperature is very low, we say that the gas is difficult to be liquefied. Say for example, if there are two gases A and B, one has got critical temperature of 50 degrees Celsius, other has got critical temperature of -2 degrees Celsius, let us say. So at any temperature below 50 degrees Celsius, A will be present in the liquid form, but B will stay in the gaseous state until unless this low temperature of -2 degrees Celsius is not achieved. So if it is asked that out of A and B, who is liquid at room temperature? So of course it is A, because room temperature is below 50 degrees Celsius, but above -2 degrees Celsius. And the critical temperature of any gas gives us the measure of intermolecular forces of attraction between the gas molecules. The gases which can be easily liquefied are said to be easily liquefiable, which indicates that they have strong intermolecular forces of attraction. So when we are talking about So when we are talking about the critical temperature, so we will have to understand that lower the critical temperature, difficult it is to liquefy the gas. And that is why we can say that out of A and B, if it is asked that which one has got greater force of attraction, what will be your answer? Which gas do you think has greater force of attraction in between the molecules? Gas A or gas B?
A.
It is gas A. Why? Because A can be easily liquefied, B cannot be. So such kind of gases which have relatively high critical temperature are said to be easily liquefiable. Okay. So we can write in general, easily liquefiable gases are more readily adsorbed. As for example, NH3, HCl, SO2, Cl2, etc. readily gets adsorbed than permanent gases such as O2, H2, helium, etc., which have low critical temperature. Which have low critical temperature. Okay, so the gases like O2, N2, H2, helium, etc. have very low critical temperature. They are difficult to be liquefied. And because they are difficult to be liquefied, so they have poor intermolecular forces of attraction. And that is why we see that they are poorly adsorbed. It is relatively difficult to adsorb such kind of gases. But when we talk about the gases which have relatively high critical temperature, those which are easily liquefiable, so you can see that relatively they have got, they can be easily liquefied as compared to those which are permanent gases. Though the term permanent gases were initially used thinking that they can never be liquefied, but even though all gases can be liquefied, provided you can achieve that critical temperature for everyone. Then comes point number 3, effect of temperature. So I have already discussed the effect of temperature on both types of adsorption. Can anyone explain what is the effect of temperature on the Physisorption and what is the effect of temperature on chemisorption? Yes. What is the effect of temperature on Physisorption? Tell me. Today itself we have discussed. It's not new. What is the effect of temperature on Physisorption? Aditya, Bhargav, any one of you? Akanksha, Hridayangam, Irfan. What is the effect of temperature?
Sir, in physiosorption, it will decrease with the increase in temperature, and in chemisorption, it will first increase, then it will gradually decrease.
Very good. So, effect of temperature varies in Physisorption as well as Chemisorption. In Physisorption, adsorption decreases with rise in temperature, whereas in chemisorption, it first increases and then decreases with rise in temperature, provided the pressure is kept constant at constant pressure. So I have also given you the graphs for both of them while discussing the differences between Physisorption and Chemisorption. Point number 4. Surface area. The surface area also plays a very important role in the rate of adsorption. So generally, if you want to increase the rate of adsorption, you need to increase the surface area of the adsorbent, because it is like saying that if you take a piece of large charcoal, a block of charcoal, and if this is a block of charcoal, say, and same charcoal you convert it into pieces, out of these two, where do you think the surface area is higher, the first one or the second one?
The second one.
Second one, because the moment you convert it into powdered form, you will see that it has got greater surface area, and when it has greater surface area, so it is in position of taking in more amount of adsorbent, and this is how we can increase the rate of adsorption. Increase in the surface area of adsorbent will increase the rate of adsorption. As for example, powdered charcoal has greater adsorption capacity as compared to block of charcoal. Clear? किहर कारणे powdered charcoal has greater capacity of adsorption? Because the powdered charcoal has more surface area. So hence we can say that if you increase the surface area by making it into powdered form, So it will have greater capacity of adsorption. I hope the points are clear to you. They are not very difficult to be understood.
Yes, sir.
Okay. So one more factor, which is effect of pressure, which requires to be discussed in details, will be discussed in the next class, because under this topic there is a very important adsorption isotherm. When we are talking about effect of pressure, we need to keep the temperature constant, and if you keep the temperature constant, so we say that it is called an isotherm. The graph that is obtained is called an isotherm. So that we will discuss next class, but the topic will remain the same. That will be the fifth, you can say, factor that will be affecting the adsorption process. Okay.
Yes, sir.
Okay. Thank you. So next day we'll continue further with factors affecting adsorption. See you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Number 5, effect of pressure. Effect of pressure. So before we try to understand the effect of pressure, we all are familiar with the fact that suppose if you consider an adsorbent, okay, and this is the adsorbate that is supposed to come. So if you apply pressure on the adsorbate, that means you will be able to force it down. Okay, putting more pressure means you will be putting force on it, and as a result of it, you will be capable of making the process of adsorption faster. So that is why we say that when we talk about the effect of pressure on the adsorbate, the more pressure you exert, the more will be the rate of adsorption, because you are forcing the adsorbate to get adsorbed in a faster manner. Are you getting my point? Because as such, the adsorption was taking place. But what will be the role of pressure when you are putting pressure on the adsorbate? What will happen to the, you can say, the process? Will it not become faster? And the rate of adsorption will be higher or not when you are putting pressure?
Yes.
And all this process that you are carrying out must be carried out at constant temperature. Why? Because see, both temperature and pressure are equally responsible to hamper or to alter the process of adsorption. So if you are interested in calculating the effect of temperature, you have to keep the pressure constant. And if you are interested to calculate the effect of pressure, you have to keep the temperature constant. Now, it has been calculated that if I plot a graph between extent of adsorption versus pressure, the graph is something like this, which suggests that when you consider this particular portion, it's a linear line suggesting that x by m is directly proportional to P. So as you keep on increasing the pressure, the x by m will also keep on increasing linearly. Now it is from this to this point. Why? because as you can see, this is a straight line increasing in this particular manner, suggesting that the more you exert pressure, the greater is the rate of adsorption. But from this point to this point, we can see that X by M is independent of pressure, isn't it? Why? Because when any line is parallel to that of x-axis, what does that mean? It becomes constant and is independent with respect to the x-axis. That means what? X by M is proportional to P to the power 0. So P to the power 0 means what? It is proportional to 1. So hence we can say that when we talk about the effect of pressure on the rate of adsorption, or when we talk about the pressure depending upon the extent of adsorption, so initially it is directly proportional to pressure, and when we are talking about this region, it is independent of pressure. So how to explain this phenomenon? Why is it happening that initially it was independent, it was directly proportional to pressure, and thereafter it is becoming independent of pressure? The reason is very simple. Initially, when you took the adsorbent, it had, you can say, vacancies on its surface. And therefore, when you are putting pressure on the adsorbate, you could make more adsorption to happen. The more you exert pressure, the more will be the rate of adsorption. The more amount of adsorbate could be adsorbed. But this will continue as long as the vacancies are present. But soon a time will come when all the vacancies will be completely filled up. At a time ahibo jetia tumi jimane pressure exert kora kono labh nohobo, karon adsorption hoar karone vacancies must be present on the surface or not. Yes. So this is the point which is called the saturation pressure. This is the point which is called the saturation pressure, beyond which jodi tumi further you can say pressure exert kora kono labh no hobo. So why do you think there will be no use beyond this point after applying the pressure? Can you tell me?
জাগা বাকি নাথাকিব।
Because there is no open space left. There is no space left rather for the adsorbate to come in. So no matter whatever pressure you exert, there will be no use. And that is why we can say that initially the rate of adsorption is directly proportional to P. But after the point of saturation is obtained, this is the saturation pressure. Beyond this particular point, it becomes independent. So X by M is proportional to P to the power 0 here. X by M is proportional to P to the power 1 here. And this is the point at which there is a bifurcation going on. There is a change going on. So we can say that here X by M will be proportional to P to the power 1 by N, where 1 by N lies between 1 to 0. So this was P to the power N, this region it is P to the power 0. So obviously this region where there is change going on, so it must lie between 1 to 0. And that is what has been stated, that if I express the whole equation in terms of X by M proportional to P to the power 1 by N, so we can say that 1 by N takes the value of 1 here, 1 by N takes the value of 0 here, and 1 by N will lie in between 1 to 0. So this particular graph that we have discussed is also called freundlich's adsorption isotherm. Freundlich's adsorption isotherm. And why is it called isotherm? Obviously, because as we are studying the effect of pressure, we have to keep the temperature constant. Any point not understood, please tell me.
Sir, why it is 1 by n?
1 by n is just taken into consideration so as to make the process of calculation easier. I'll tell you, because it is exponential value, and because it is exponential value, so it will be easier if we convert it into logarithm, and when we calculate or convert into logarithm, so it will be easier for us to calculate the value of 1 by n. So rather than taking the value of n, we are taking at 1 by n. So what can I write at very low pressure? At very low pressure, can I write x by m proportional to p to the power 0? Yes. Or p to the power 1 at very low pressure? Yes or no?
Yes.
At very high pressure, what can I write? X by m proportional to p to the power 0? Yes.
Yes.
At intermediate pressure, x by m proportional to p to the power 1 by n, where 1 by n lies in between 1 to 0. So at different pressures, you have different relations between x by m versus p. Have you drawn this graph? Have you completed this graph? Can I proceed? Can I rub it?
Yes, sir.
Oh. Now, when I generalize this, for every condition, we can write x by m proportional to p to the power 1 by n, or x by m is equal to kp into p to the power 1 by n. X by m equal to k into p to the power 1 by m, where k is the constant of proportionality. If I put log on both sides, okay, if I put log on both sides, can I write log of k plus 1 by n log of p? Yes or no?
Yes.
So log application makes the multiplication into addition. And accordingly, if I put log on each and every individual component, we get this. Now this equation is equal to y equal to mx plus c, which means that if I plot a graph between log of x by m versus log of p, then you get a straight line not passing through the origin. The intercept will be log of k and the slope will be 1 by n. So same graph, which was not a straight line, and was showing change from time to time now becomes a straight line. And now it is easier for us to understand the values of 1 by n if I plot log of x by n versus log of p, giving us an intercept of log k. This is also Freundlich's adsorption isotherm. Both of them are Freundlich's adsorption isotherm, with the difference that the previous one was non-logarithmic and was not giving us a straight line. But if you want to convert that to straight line, so we need to apply this. So this is the effect of pressure on rate of adsorption. So whatever we have learned today is initially when you exert pressure, the rate of adsorption increases, keeps on increasing until a certain point, beyond which if you further exert pressure, there will be no effect of pressure because of the reason that all the open spaces that were available have been already filled up. And at the point of saturation, you cannot observe any further adsorption because rate of adsorption becomes equal to rate of desorption. So at that point, we have already discussed, equilibrium is established. And hence, for different type of pressures, at high pressure, at low pressure, at intermediate pressure, we have come across this relation where 1 by n keeps on changing from time to time. For, of course, very low pressure, 1 by n was having the value of 1. For very high pressure, 1 by n was equal to 0. And for intermediate pressure, it lies between 1 and 0. And thereafter, we have converted into logarithmic form and we get this particular equation. Understood?
Sir, graph is not visible.
The complete graph is not visible.
No, sir, lower portion.
Is it okay? Is it visible now?
Yes, sir.
Sir, what if the value of log k is 0? Sir, if the value of log k is 0, sir, then what will happen?
Log k is 0 means there will be no intercept and you get a line passing through the origin.
Okay, sir.
It becomes y equal to mx. Huh?
Yes, sir.
If it is y equal to mx, then you get a straight line passing through the origin. Okay?
Yes.
Why these graphs are called isotherms? Can anyone tell me? What is the meaning of isotherm?
Constant temperature.
At constant temperature. Because if you are interested to calculate the effect of pressure, then temperature must be kept constant. And if you want to calculate the effect of temperature, then pressure must be kept constant. So both cannot be changed. Otherwise, you won't understand which actually is affecting the process of adsorption. Clear or not?
Clear, sir.
So with this, we come to an end of the first part of surface chemistry, which comprises of the adsorption. Okay, so adsorption, 3 total classes I have taken. In your sections 2 I have taken, and the middle class I took it in class 11, 12A. So you just combine these 3 and go through them. So after this, I'll send you the probable questions that may be asked on this particular topic. So next day, We'll continue further. What is the second portion after adsorption? I told you. Do you remember? This chapter has been subdivided
Catalysis.
into catalysis. Very good. So this is further subdivided into three. One is obviously adsorption. Second one will be catalysis, and then colloids. Okay. Thank you. See you in the next class. Bye bye.
Thank you, sir.